didn't know what they're trying to say, you just try to approximate, give the exact value. Then you differentiate this, you know how to do that, right? Yeah. So that's 15x squared. And then they're like, oh, what if it changed by 3%? You have to calculate all that. You could. You can do it within like 10 minutes. So when they say approximate, remember like really, really small changes thing we talked about last year? So 3%, they're saying, they're implying it's small enough for our purposes. So if it's really, really small, right? So then use a different delta. A small delta is, if it's just 3%, you know, let's say 3% change. That's what they're saying. What is the change in volume? What is the new volume? Let's say this is the original. Let's say whatever this is, you know. You change by 3%. Yeah, we'll say original, but then what's the next volume, you know? What is that? That's what they're saying, approximate. That's what it is, right?
Yeah.
So it's a change in volume 3%, so 0.03, right? That's the change, 3%. And then that's what we're gonna figure out, what's dV. Okay? That's gonna be the same as that. So then that thing you put, because for real small changes, that's what it is. Approximating. That's what you're doing. So then you're looking for this, right? So that's gonna be this thing, right? Times this thing, treat it like a fraction because it's approximate. So that's going to be that 15x squared times 0.03, whatever the change is. So then that's what you add to this. You change by that. So I'm just going to write the whole thing. Whatever this is, right, times 0.03. Yeah, that's what it is. Because it's so small. The idea is like, in a curve, when you look at those rectangles, remember?
Yeah.
The big rectangles is really, really crude, right? But they're really small. You make it really small. That's the idea. Then you're saying it's pretty flat. You're assuming it's flat. So then you're assuming that's going to be same. That's what you're saying. That's why they use the word approximate there. And the percentage is pretty small. Usually should be like 0.3%, 1%, but when they say approximate, then you use this formula. That's what it is. 1133336, right? And then same thing here. 1133336. So that's what you would do, right? So it's 36. Out of 36, you make a table, right? When is it 6? Either 36. Yeah, but you don't have to give every single one. You just say which one, right?
Yeah.
Like the ones don't have it, the sixes don't have it, right?
Yeah.
It's just the 3 threes. So how many is that?
No.
So 9 out of 36 is the probability, right? Let's say success, you know, yes, no, right? Yeah. Probability of success, right? So everything else is just none. Yeah. Which is what?
27.36.
Yeah. Okay. Yeah. So 3 times when you get 3, so that's the probability of getting a 6, right? So you already got part A. Now what's the expected mean value based on chapter 8? 6, 6, 6, right? And then you put the other numbers. You add them all up, right? Let's not do everything, but pick all the different numbers. What are the possible numbers? Besides 6, let's try like some of it. 12 over here, right? 12, and then this would be 9, right? And 7, right? So you sort of see it, right? 4s, maybe, right? 7, something like that. You just keep doing it. And 2s, right? The 4s here, 7s here. And how much you get the expected mean out of this? What do you do? Let's say you fill up the whole table, what would you do? 9 out of 36 is when you get 6. Let's just do this. 6, right? Then you just make others. We got 7, we got 9, 12, right? And 4, 2. Make a table for that. So how many 4s are there?
12.
Yeah, 12, right? 2s would be 4, I think. That's it.
Yeah.
I'm not reducing the fractions because there's no need to, but also it's easier to see it this way.
Yeah.
How many sevens?
4.
Yeah. 9 should be 6, right?
Yeah.
12 is 1. Do they add up to 36? If you did it right, you're gonna add up to 36. So that checks. Yeah, so now you have the table. How do you find the expected value? You can do it in a calculator really quickly, but they say show it without a calculator. So what you do there? Yeah, number of trials will be 36. N, right?
Yeah.
Chance of getting a 2 is 4 to 36. So you multiply them.
Yeah.
And you add them. So you got 6 multiples and you add them all up, right? Six results, probabilities, add them all up. Actually, the probability already incorporates the number of trials, so you just add them up. Chance of getting a 2 is 4 to 36 plus whatever. That's it. Don't divide by 36 again. Yeah, you divide by the trials when you do it all like this, one at a time. You add them all up, divide by 36. That's the expected value. And the mean. And here you got the probability already, so just multiply and add it.